Good morning, good afternoon, and good evening, everyone. So today we're going to be continuing our exercises on double integrals over general regions. And here we stopped at this item here where we set up iterated integrals for both orders. And so type 1 is when we first integrate by y and then by x. And type 2 is vice versa. Or honestly, it could be the other way around. Doesn't really matter. And then from here, we just find which one's the easiest to do, right? So, okay, let's move on to the next item because I just said I was going to go through these exercises bit by bit. So the next exercise tells us to evaluate a double integral. So how are we going to do that? Well, let me just write it first. So, okay. So here we're given a double integral. So here, that's our double integral. And then from there, we say that D is some sort of triangular region. So now it's a triangle. And it has vertices 0, 1, 1, 2, and 4, 1. Right? Now, how do we find, or how do we, so our goal is to make it an iterated integral. So that way we can solve it. But how do we find the bounds for y and x in this case, right? So that's our issue. Let's see. How do we do this? So the first thing we can do is find the lines, right? Because at the end of the day, these are lines. So the line from 0, 1, oops, what am I doing? From, oh. So from 0, 1, this is not drawn to scale, by the way. 1, 2, and then 4, 1, right? So we have 3 lines here. One line is this line. Another line is this line. Another line is this line. And we want to find those 3 lines, right? That's how we're going to get this region. And so, okay, let's find the line through 0, 1, and 1, 2. What's that going to be? So here, again, find bounds. Same idea. So for line, we'll just call it L1. And it passes through, let's say, this point and this point. And this is going to give us some equation, right? Y equals some slope here, 2 minus 1, 1 minus 0, x minus, or x plus 1. Right? That's the equation of that line. And so this gives me y equals 2x plus 1. Where if I plug in a 0, I get 1. I plug in a 1, I get 3. What? Is it just 2x? Oh, shoot. My bad. It's just 2x. Yeah. So here you have y equals 2x. Right? So that's line 1. Now we find another one. Line 2 could be through, let's say, 1, 2, and 4, 1, right? So again, it's the same idea. Y is 1 minus 2, 4 minus 1. And this is x minus 1 plus 2, or something like that. And this gives me an equation that goes So this is 1 minus 2, that's negative 1. So negative 1/3 of x minus 1 plus 2. Right? So that's another thing. Then lastly, line 3, or L3 in this case. So, so here it passes through 4, 1 and 0, 1. And here we notice it's just 0, right? So here it's just y equals 1, right? Wait a minute. Do what? This is do wait a minute. 2 minus 1 is x. Uh-oh. Ah, and then the plus 1 here. Okay, this gives me x plus 1. Okay. So there, now we have the equation of the lines. And then what are we going to do with those? Now we basically want to set up a double integral with the appropriate limits, right? So it's that idea of, well, setting it up with the appropriate limits. So how am I going to do this? Well, we need to find bounds, right? If we were to do this dy dx, I'm going to try dy dx. Then this is fine, right? Because how we did it previously here, if we want to do dy dx, we have to set y to something, to some x. So here we already kind of did it, right? Trying to think. Yeah, we have these equations, right? Yeah, here's my issue. I don't know which one do I put. I have 3 things here. I don't know what to put. What do I want to do? This one doesn't make sense-ish. It's because of this 2 here? Is that it? Well, not super sure. I mean, you know what? Let me try. Uh, yeah, I think that's my issue with these stuff, is I don't know how to find the bounds exactly. But I could do it, right? Oh, so the mm, 0, 1 to 1. Hmm. Wait. Yeah, the idea is we want to analyze how this region will look like. That's the issue. And so even if we were to find the lines and then set up a double integral, then we need to find constants for x here. Okay, so in this case, when x is 0 to 1, that one's the issue. So when my x is 0 to 1, right? Where did I get 0 to 1? these two. That's y equals x plus 1, right? So bottom would be y equals 1. Top would be that, x plus 1. That's the top, right? And then for my line 2, so let's say this is when x goes from 1 to 4. In this case, this is from 0 to 1, this is from 1 to 4. 4 to 0. 1 to 4. So yeah, this is when bottom is again. Y equals 1. And then top here is this function. Would there be a nicer way to simplify this? Do I do it though? That's a 6, 7/3. Let's just do it. I don't know. I feel like this might be better off. Oh, that's tricky. See, just the fact that this thing looks more complicated than it already is. So if I integrate by x first. Oh, integrating by x is it's easier, I would say. Yeah, because here I would split the integral. I don't want to do that. Okay, let me just go ahead and do this part. Let me just integrate with respect to x first and then y, because I feel like that might be easier. So the y limits would be y equals 1 to 2. How do we know it's from 1 to 2 of y? I have like a couple of things here. So it goes from 1 to 2. That's the y limit. And so my x limit is something else. So that's when I make this x equals y minus 1. And then this one, well, this is y equals negative 1/3 x minus or plus 7/3. I could multiply a 3, right? So this could be like 3y negative x plus 7. Uh, I could plug this in. So I would say 3y minus 7. 7 minus 3y is x. So this, in fact, looks easier. And then from there, my limits for y are y equals 1 all the way to y equals 2, right? Then my limits for x, well, these are the following in terms of y. So here we have y minus 1 and 7 minus 3y. So I don't know, we play around. So we plug in a 1. Which one is bigger? If I plug in a 1, this is 0. If I plug in a 1, this is 4. So this one's bigger. or y minus. Depends on what y I plug it with. I plug in a 1, this is 4. I plug in a 1, this is 0. That's greater. I plug in a 2, this is 1. 2, this is 1, so it's kind of the same thing. So it could be this or equal, depending on the thing. So this is x equals y minus 1, x equals 7 minus 3y. So depending again on which one is bigger. And so for the most part, this is going to be bigger as my y reaches 2. So that's the indicator that, okay, this works. So we do 1, 2, integrate with respect to x first. This is y minus 1, 7 minus 3y of my function. My function is 2y squared. I integrate by y first. It's looks like a y first integration thing. Or no, my x. Whoops. My x. Then my y. Yeah. And so I solved this integral, right? How would I do that? Well, so this gives me y minus 1, 7 minus 3y, 2y squared dx. This is a constant, so I can just directly integrate or out of it, right? So I get 2y squared, some x value of y minus 1, 7 minus 3y. I get 2y squared of this. 7 minus 3y minus y minus 1. And if I simplify this, just to make it clean, 7 minus 3y minus y plus 1. So 7 minus 4y plus 1. 8 minus 4y. And I think I could combine all of these. So I get 16y squared minus 8y cubed. And then I solve for this integral now. So I got this. Now I solve for this thing. So this, I think this is personally what I find confusing, is I don't know how to do this in one go. This is squared 8y cubed dx, dy, I mean, dy. So here, yeah, I pretty much just straight up integrate this whole thing. So this is 16 over 3y cubed. This is minus 4, let's do y to the 4th of 1 and 2. Then from here I can factor out. Actually, let me just factor out from the beginning, because it's really... Let me factor out an 8. So I'm left with 2y squared minus y cubed dy. So here I'm left with 2/3 y cubed minus y fourth over 4 of 1 and 2. And this should give me some value. So 2 cubed, that's 2 cubed is 8. 8 times 2 is 16/3 minus, this one's 2 to the 4th. That's 16. Oh, it's 4. Then I subtract that with something. 1, that's just 2/3 minus 1/4. Subtracted with that. So here I get, what is this? By 3, I got 12 here. 16 minus 12, that's 4/3, right? Minus 2/3 minus 1/4. I make both of these 12. This is 4, so this is times 3. This is 3. This is times 4, it's 8. 8 minus 5 is 8 minus 3 is 5. 5, 12. And this becomes 12 times 4. This becomes 16 minus 5. That's 11 over 12. I can factor, completely cancel, or no, 2, 3. 22 over 3. That should be the answer. Right? Yep, solve that all in one go. Definitely. So the next time I see that, I pick an easy integral to solve, right? That's what I want to do. Okay, let's get more practice on doing this. This exact step. So here, again, we're being asked to evaluate a double integral. What would that be? So we have this, the 7xy squared, change in area. Here my d is enclosed. So again, another general region by x equals 0 and x equals square root of 4 minus y squared. So again, this is one of those instances where we differentiate by x first, where we integrate by x first and then by y. Right? But that was my y. That's another thing, another story to tell. So I have my x bounds, but I don't have my y bounds. Here I have my y bounds somehow with the vertices. Here I have my y bounds through here. Right? So again, it's this idea of finding points of intersection and then determining the type and then seeing which one's easier. Right? So let's try to follow that pattern, yeah? So here I have a system where I can just plug it in. So again, here I'm just gonna find points of intersection. Then I'll determine the types. So points of intersection, we have a system here. X is this. X is also this. So here we get 0 equals this. Right? If I square them, I get this. Put the 4. Or put my y. Here I get actually plus minus 2 for my y. My x is always 0 in this case. But then if I have this for my y, now my x can be, I can plug this in. So I get 0. Amazing. Yeah, I get 0. So that's my y, right? That's my y. Negative 2 to 2. So here, find integral and solve it. Basically what we need to do. Let's put our y values here. We have negative 2 and 2. Then let's put something that we assign to x with. Since you already have that, might as well just do that first. 0 and then square root of 4 minus y squared over my function. So an xy squared, and this is dx dy. Right, so that's a way to do it. Now that I realize it, I think I know what's the easier one. The easier one is what's by default. Yeah, this one looks easier. Because if we have the squared here, then that's harder, right? Yeah, because here I didn't take into account the negative, which is another story. So this one's definitely harder because there's a negative. So as much as possible, I want to not have that, right? So here in this case, where am I? This one's easier. This one I think might be the easiest. I don't want to derive it anymore. Difficult. I mean, we can, maybe ish, but I'm gonna have like two square roots here. So might as well not, right? So yeah, this one has to be it. Okay, let's solve it. We have 0. This one's just a number, so no need to worry about it. My 7x I can just put out. Or no, kidding. My 7y squared I can put out. Let me quickly do that. And then I immediately, oh, that's fine. Just put all of it. This is my x dx. Then here I integrate x squared over 2. Or, that's fine. It's fine. It's fine. 0. That. Take out my 2. Oops. There we go. Then what do I get? Here I get, oh, this one's squared. Look at that. There we go. Nice. And then I think we can make this really, really nice. We can put my y squared here, so I would get something like 7/2. This is 4y squared minus y to the 4th. I can even do more stuff, and I can say this is, okay, 4 to 1, 14. This is minus there. I'm gonna write it that way because I want it to look more like a calculus type of thing. Okay. Does that make sense? 28 divided by 2, yeah. This is, yeah. That looks nice to me. And then from there, now I integrate it with respect to y. Negative 2 to 2. So here I do that same thing. Oops. 7/2 y to the 4th dy. Here I get, oh boy. I integrate this whole thing. So I got 14 over 3y cubed. This is minus 5 minus 10. Then this is y to the 5th. Then I have that. Okay. And then I put my two. Why is it so much? Anyway, I got. Let me just do it. I'll solve it like right here, right now. This is 2 cubed. That's 8. 8 times 14. 112 over 3. Subtract the 2 to the 5th. 32 times 7. 32 or 10, 32. Okay, my 10 here becomes a 5. This one becomes a 16. So I have 16 times 7. Oh God. 112 over 5. So I get that value. 112 over 5. Oh, nice. I totally erased it. That's fine. I get that value for my first one. And then this is common denominator of 15, right? So I multiply this by 5. This gives me 560. Oh my goodness. This is 15. Multiply this by 3. 336. 560 minus 336, 224 over 15. So this is, okay, that's the first one. I subtracted 2 when I multiply negative 2. This is negative 8. So here I get negative 115 again, I think. 112, oops. Negative 112 over 3. This one is also the same thing. right? So this is actually, oh, but then the difference is now plus. So minus or plus 112 over 5. Okay. Yes. Okay. And then we make it all 15. This is a 3, so this becomes, well, again. So now this is a negative value, right? Anyway, 560. Oh, no, this was the 300 one. Cool. Okay. The 336. Now I subtract both of them. This has a different number. So this is negative 224 over 15. So actually add these two. 336 over 15. I get this value. And I think I can simplify that even more. Although that, I get 224. That's my answer. Right? Question mark? No question mark. Let's see. See if I actually got that value here. So we got a different one. What happened here? So I messed up my limits, right? So region D is enclosed by x equals 0 and x equals... Oh, wait a minute. No, he messed up. Whoops. Oh, whoopsies. So this is square root. Uh-oh. Then by dx, then... Oh, we have the same like value here. Oh, I get a different number. What do I do now? Mm-hmm. Let me see. I don't know. I might probably an integration technique that I didn't know. So okay. So what happens? You got a different thing. Okay. Or wait a minute. 7.5? Where did my 7.5 go? Did I use a different? Oh no. Don't tell me I what? Am I lost? Wait, what happened here? Oh, 7xy squared. Okay, okay, okay. I was like lost for a second. Wow. Okay. Yeah, that's squared here. Yeah, this. I got that part. Okay, I got that part. Yes. And then from there, you just straight up integrated that whole thing. I combined it to get my y. Yes, he factored it out. Mm-hmm. Oh, and I did the times two. If okay, probably computation error. But if I did get this, am I wrong? Or I don't know. Y squared. Yeah, put my y squared here. And I have a 3 here, I have a n. Apparently it gave me that number. I don't know, if I'm gonna be totally honest. But my process was similar. It was very similar. It's just that it's this issue mm, of computing. Computing it is very weird, I would say. Yeah, computation of this is not super, super friendly. So next time when I see something like this, I'm not gonna combine it. I'm gonna leave it be. I'll leave it like that actually. Let me leave it like this. I should probably leave it like that. Okay. So actually, let me do this. 7 half, 4y squared minus y to the fourth. Let's leave it like that. Now let's try integrating again. See if we get the same value. So here I'm gonna have immediately take out that 7 half. This is 4y squared minus y to the fourth. Right? 7 half then becomes, so this becomes 4 third y cubed minus y fourth to the fourth over 4, I mean. I have that. Another way we can make this easier is if I multiply by 2. But that's assuming I'm symmetrical, so I'm not gonna do that. It would make it easy though, but nah. Let's let's try this one. So here this would give me, let me try it again. 2 cubed is 8. 8 times 4 is 16. What? 8 times 4 is 32. What am I doing? 32 minus over 3 minus 2 to the fourth is 16 over 4, so that's just 4. So that's 12 thirds, or 12 over 3. 32 minus 12. If I'm doing my math, that's 20 thirds, right? Minus something. If this was -2, it would just be that same thing. So negative 12. Oh, oops. -8. What am I saying? -32. That's -8 times 4, -32. Thirds, and then this is minus, or in this case, plus 16 over 4. So that's basically 4 12 thirds, right? And I have 12 minus 32, which is just -20, right? And I basically just add it here, so I get 40 over 3. Then, what? What? 40 over 3? Am I brain dead? There's no way. This is 40 over now I'm getting different values. That's funny. Oh no, 40 over 3 times 7 half. There we go. And I factor this, I get 20. Oh, this becomes 1. So this is 1. There's no way. 7 times 20. Still get a different number. That's not nice. That is not nice. Uh, wait. I think I'm messing something up. Or no, maybe this might be similar. When I multiply by 15, it's 5. That's no. That's not, nah, you can't do that. Where am I messing up? Okay, wait, wait a minute. Let me try this. I have no idea. This is some stupid computation. Very, very stupid. This is why I don't like computing. So annoying. Integrate with respect to x first. Okay, continue. I'm even letting GPT do it because I'm just super annoyed. This is extremely annoying. Watch it get a different value. That one's gonna be funny. Oh my god, it got different value. There's no way. Oh god. Fine, fine. I'll just answer what this gave me. There's just no way. Wait, actually, I don't want to trust it too much. That's the thing, because I feel like my computation's right. Because you multiplied it by two, which is weird. I know GPT is just wrong. I did get this, which is also a bit weird. Because, okay, what the hell? This is, yeah, I squared it, so this should be a nice number. I get this, right? Because this one we're the same. And then I reach this part, I integrate, oh, now I see where I messed up. This is to the fifth. Cool, cool, cool. So, and then what happens? We have 2 cubed. Let me actually just write it. 832 thirds. This is minus 2 to the fifth. So that's 32 over 5, right? Yeah, that's where I messed up. God. Okay. And then the other one was, what was it? Minus 32 over 3. Then this one is a plus 32 over 5. So basically anything I do here, this 15 times 5 times 5, that's 160. Minus, this is 15 and 96. So this, okay, minus, this one is again 15, 160 plus 96, 15, and then I get 64 minus this value minus 64. So I get 64, 128 over 15, right? No way did I mess it up again. What am I doing now? uh, that's funny. Oh, now I multiply by 7.5. Okay, I'm done. So, okay, I should actually do it step by step because then I can't really validate my solution if I don't do this step by step. Especially now that we're incorporating integration again. This gives me 64. And then this is what I think it should now be. There we go. Okay. Goodness. Yeah, I also need to be careful about integration. Okay. Or maybe I'm sleepy. Not super sure. So this is 448 over 15. That was annoying. That was extremely annoying. Okay, I have like a couple more to go, but we can get through it. 7, 8, 9, 10, 11, 12, 13, 14. Yeah, I have like 8 more to go. Okay, so 7, I want to find volume under solid, or that lies under that solid. So this is this idea of finding solids again. And now we have some surface. What is this? This is not even vector calculus. It's just integrals and computation. And it's above region enclosed by, okay, so now we have something again like this. So same idea, x equals y squared, as well as x equals 4. So here's the plan. How do we do this? We can integrate by dx and then dy. We can do that. And I think, honestly, that one's the easier part. Right? And then we're also given this surface. So let's just go ahead and find it. So here we just find integral and solve it. Oh, speaking of integral, I need my bounds for y. So I need to find my bounds here for y specifically. So I have to solve this system, right? When x is 4, we actually just say y squared is equal to 4. And so this tells me that y is plus minus 2. Those are my y bounds. And so I now find an integral and solve it. So here, this would give me, this is so annoying. Okay, this anyway, this gives me, so for my x, 4 and y squared. Which one's greater? Is it my 4 or my y squared? Which one's the upper bound? If I plug in -2 here, what would my x be? 4. If I plug in a 2 here, it would be 4, right? So what does that tell me? If I plug in something like a 1, so my 4 is actually greater than my y squared in this case, right? I'm just trying to assume. Wait, am I right? What the? Yeah. So I have to kind of do that thing as well, where I have to check which one's the bigger bound. If we were given like some sort of function and then this thing. So I would say, yeah, in between these two y values, let me say, 4 is bigger. So I think it should be like this. I might be wrong. So I'm gonna check already. But I feel like that's how we do it. Okay. Let's see. See, this is why we don't need math anymore, because you can just GPT it. Anyway, I'm done. Yes, okay, got it. So now we plug in my function. It's just this thing. Y plus x squared, y squared. So again, okay, here we combine these two. And then this is, I believe, derive it first by x and then by y. So it's that thing, right? And then from there, what do we know? Oh, we just solved it. We don't know anything. I'm just gonna solve it. dx. So here we can actually split these, right? 1 dx plus. Oh, here we assume that, oh no, what am I doing? We assume that x is the variable. So that means my y is going out here. Now my x squared in here. Hello, hello. Okay. So here this would just be 4 minus y to this y squared. This one is a bit different. This is y squared integrated by x cubed over 3 of 4y squared. And so this would give me 4 minus y squared plus y squared of 4 cubed is, what's that? 4 times 4 times 4, 64 over 3. Y squared, so that's y to the 6th over 3. Okay, I'm not gonna So this one's now going to give me plus 64 over 3y cubed. Oh, what am I saying? Y squared. Whoops. And then this one's going to give me, if I multiply, 1/3 y to the 12. That's a weird thing. Cool. Let me see if I got it, because I feel like I messed it up again. Oh, shoot. Yeah, I did. So we're not multiplying, we're adding. I, this is 8. Yeah. So thing about exponents is when we multiply them, we basically add their exponents together. Okay. And from here, oh, I can simplify that. Yeah. This just gives me 61. So I get minus 1/3 y to the 8th plus 61 over 3 y to the squared. Y squared plus 4, right? Here I can make it nice. I could try to make it really nice here. So I'm gonna secretly do that, right? Okay, give me a volume. I'm gonna do that real quick. I'm gonna say we got this, right? Here, because there's a 3 in here, so I kind of wanna. I'm tempted. So what I'm gonna do here is a bit cheeky. This is negative 2, 2. I'm gonna say this is 1/3, right? Y to the 8th plus 61 third y squared plus, now this is gonna be 12 over 3. Then that way I can factor out a 3 in here, right? So if I factor out a negative, a 1/3 here, or even no, I'm gonna factor out a 1/3. So if I factor out a 1/3 here, I would get this thing: negative y to the 8th plus 61y squared plus 12 over plus 12. I don't know if that's a big brain idea. I just thought of it. And then, oh shoot, that, oh, that's scary integral. Okay, and then from here, well, now we just integrate this whole thing. So we have y to the 9th. And then here we get, whew, 61 third y cubed. And here we get 12y. And then we solve that whole thing. Okay, let me actually be a bit more nice here. So this is 2 to the 9th. Negative 2 to the 9th is 512 over 9. Can I simplify that? I want to make it clean. Oh, 2 cubed is 8. 61 times 8 is 448. This is to the third. And then this is 100. Oh, no, I'm kidding. 24. Yeah. Let me actually put this here because I know it's going to be a heck of a long ride. I'm going to subtract it to here. This is minus 2 to the 9 gives me an odd number. Oh, no, a negative number because it's an odd exponent. So I'm going to leave it positive. So we have 512 over 9. This one is a negative number, so this is minus 448 over 3. And then this one is 24. So this is minus 24. Right? And so what basically happens here is that I multiply everything by 2. Yeah, I should have just done the multiplication by 2. That would have been nice. So if I solve for one of them, I solve for all of them. So this gives me, oof, what in the world? This gives me a 9, 512. I could make this a 9. 448 times 3 though is 100. Good lord. And then 24 times 9 is 216. If I'm not doing my math wrong. And I keep going here. Oops. This gives me 512 over 9. minus 134. So here I just copy numbers. Copy numbers, copy numbers, copy numbers. Here I get some value. So here oops, I get a 512 plus 1344 plus 296. This gives me 1048 over 9. And this is minus, I think I get a different number. This is negative 1048, right? That's just a guess. 512 minus 1344 minus 216. Yes, so it does. And then 1048 times itself is 2096 over 9, right? And I think I can factor this out by a 3. No, I can't. Cool. Oh no, did I? Okay. What do I do now? No way, I was following everything. Oh, did I play around too much? What did I do? What did I do? So thirds. Yeah, what did I do? I'm annoyed. I'm actually annoyed. Why am I not getting any integrals right now? Okay, I'm gonna call myself. This is minus 61 third, 4. Did I get that? Okay, I did. Is this my off day? I think this is my off day. And it's being recorded too. That's crazy. Okay, we have 1/3. Yeah. Factor out a 1/3. What's the problem? Did I not do it correctly? Did I mess up something? I feel like I'm messing up something for some reason. Okay. It's not even the integral. It's just me solving for it is somehow wrong. And I can't seem to get why. I do. This shouldn't be a problem. Uh, integrating maybe. No. Ninth. Definitely did that. This is what makes it weird. That's it. I don't want to do that. No way. There's actually no way. What am I doing wrong? What? Or am I just wait a minute. No, I'm getting that. I'm getting that value, which is weird. This is extremely annoying. Minus, plus, plus. It's even the 24. I mean, okay. That's extremely annoying. There's no way. Where did I mess up? I can't seem to find it anywhere. Wait, where's the... Okay, wait. I have a 4 here. Maybe I should have kept it simple. Gosh. Yeah, so I'm right with the first part when I integrate it. So 4 plus 61 over 3y squared minus 1/3 y eighth. And I have a 4 here. Let's try it again. I feel like I'm doing something wrong here. I just don't see it. I genuinely don't see it. Or I'm just too sleepy to see it. I don't see it anywhere. Right. If we integrate this by -2 to 2, let's just do it normally, yeah? Because I feel like, yeah, we can actually do this normally. Funny enough, we can do this normally. +4 with respect to y, right? So we just do that. Then here we basically get, so let's just integrate the whole thing. So we have -y to the 9th over 27. Whew, this one's 61y cubed over 3. That's 9. This one's 4y. Okay, I didn't mess up there, right? I don't think I did. 4. Okay, I don't think I did mess up there. No, no way did I mess up there. Okay. Now I tried doing the solving thing. So this is -2 to the 9th. That's 512. Don't ask how I know. Seen it a lot of times right now. This is 61y cubed. Y cubed is 8. In this case, 2 cubed is 8. Just double checking. It's 488, right? Over 9. This one's 8. Then I subtracted 2. A negative of this thing. So this is positive 27. This is -488 over 9. This is -8. So I basically get the value of this and multiply by 2 pretty much. So this is, I could make this all 27 because why not? This times 3. 1464. 216. And I basically just get the entire value of that, 1464 plus 216 minus 512. 1168 times 2. 2336. This is annoying. Over 27. And that should be my answer. Extremely, extremely annoying. Computation-wise. Or I might just be being careless. I might just be careless at some point. That took a while. Okay. Let's try doing this a bit faster. Let's see. Now that we've gone over the hard part. Okay, here we're being asked to find volume of given. After this, we're gonna take a break because I'm too annoyed right now. Under some surface, I don't know what surface this is, but it's an explicit equation of z. See if I don't rage here. And above triangle. So again, with the triangle, and we have vertices here. And here we have to find lines. So I think this is also one of the conceptually hard parts. Other than that, it's just the solving, which is super annoying. 1 to 2. So what do we notice? What do we notice about this equation? We can see our x going from 1 to 4. We can see our y going from 1 to 2. So either way, whichever one I work with, I should get some value. Let me just do it dx dy, right? So here again, I find my bounds. That's what I'm going to do. So I get the lines here. So some line passing. So here I'm going to get some lines, 1, 1, and maybe 4, 1. So here the equation of this would be y equals 1 minus 1 over 4 minus 1. That's just 0. And then this is x. And that's the slope. X minus 1 plus 1. So this is just telling me y is equal to 1, right? Let's check another one. this time passing 4, 1, 1, 2. So here it's really just me analyzing the patterns, stuff like that, right? So this is slope, so 2 minus 1, 1 minus 4. I do maybe x minus 1 plus 2-ish, something like that. Here I get 2 minus 1, that's 1. This is negative 1/3 actually of that whole thing, plus 2. And then here I can actually make this a bit nicer. I can say this is like this. 2 is just 6/3, so that's 7/3. Then I tried to play around with the x values, so I get negative 1/3 x. This is y minus 7/3. Now I do something like this. I take out my negative. Now it's 7/3 minus y. Now I multiply 3 to both sides. So I get x. Here I get 7. Here I get 3. So I actually just get x is equal to 7 minus 3y. Then lastly, we do a line passing 1, 2, 1, 1. Those 2 points. So here again, we do the same thing. 2 minus 1. I'll just do that. And 1 minus 1. So this is undefined. That means we have nothing there. Okay. So here we have y equals 1 and x equals 7 minus 3y. Right? Here, what we did previously, what did we get here from the line passing thingamajiggy? So here we got, oh no, that one. Where's one with the vertices again? That's the one we did. Ah, there we go. We got x equals y minus 1. Then this value. Yes, so we did get some x's. Here we only have 1. Then you have a y equals 1 here. What does that mean? Right? So here, this is when we're a bit skeptical. This is some bound, 7 minus 3y, but then what's our lower or upper bound? This goes from 1 to 2. Which one is it? Right? When y is... So here, let's just set up the integral maybe. Find integral and solve it. Again with that, right? So here I find the integral. Okay, for my y, it goes from 1 to 2. I just look at it. Here it goes from where to where. That's what I want to know. When my y is 1, this is what? When my y is 1, this is 4. When my y is 2, however, this is 1. So when my y is 1, this is 4. But when my y is 2, this is 1. This goes from 1 to 4. Right? How does that look like then? Because here, okay, I'm trying to kind of like find a pattern here. Yes, so here we did x equals y minus 1. Where did we put that? We put that at the very bottom. And then we did this. And then how did we know which one is the bigger one? Now we know y1 and 2, because we can see that here. But then how do we know which one's the bigger one from x, which goes from 0 to 4, right? How can we tell? Well, if we plug in 0 to 1 here, that's for x here. 0 to 1. Here, 1 to 4. So this one's obviously bigger. So here's same idea. Okay? When y is 1 to 4, that's 1. But the moment I go from 4 to 1, Oh, 1 to 1 is undefined, right? Oh, look at that. When y is 1, is okay, I'm confused. I'm gonna be honest, I'm confused. Can't think of a way on how to understand this in a very, in a very nice way. So yeah, I do put my, oh, wait a minute. I think I messed up here. 1 to 2. What did I do here? Oh no, did I mess up the vertices again? Oh, I didn't. What did I do here? Oh, we did dy dx, so that's nice. Okay, that's cool. X is in between 1 and 4. Y is in between 1 and 2. I did something for this. I just realized this one's easier when my Y is like this. So this is one of those cases where my Y is just easier to do. Because here I know that when Y is 1, it's just this. But when Y is going above, then it's just this. So yeah, it depends on which one's easier to do. And here apparently dy is easier. Yeah, dy is easier. dy first, then dx. And so my bounce would just be 1, 4 here. So we're gonna do this in type 2 order, or type 1, I think. Type 1 was dy dx. We're doing the type with the dy dx thing. This goes from 1 to here. Here we can see which one's greater. So that's a tip from me, for me at least, is that I have to find which one's easier to find, and then that's where I do the order. Then I put my function here. So this is 3xy. And I think this was dy first and then dx. So that's my plan, kind of, right? Okay, so I treat y as a variable, so I immediately take out my x here. I put this here. This is my y. I integrate it. Let's immediately take out my half here. I don't want to get bothered. Also, since I've actually done integrating. Ooh, so I square this thing. And I put 1 here. That's not fun. So here I do this. Minus this. That's not fun. Okay, let's see what we get. I'm gonna just do it extremely quick. See what? Nah, I don't want to do it quick because then I'm gonna mess up again. Here we have 1/9 x squared. This one is, oh god, uh, -7/9 x 7/9 x. Oh, and I square this 49/9. Here I just get -14/9 x. 14/9 x. And this one again was 49/9. Oh, that's fun. Looks nice and clean. And then I do -1, so -9/9. Or honestly, -1 is fine. Or -9/9. And then that gives me 1/9 x squared minus 14/9 x plus. Then this one is 49 minus 9. This just gives me a 40/9 here. And so that's my, okay, it's actually not that bad. Not super bad. That was going to be something that's really annoying, but cool. Okay, so here we have 3x squared. This one is I could even factor out the 9 now that I think about it. 1 over 9x squared minus 14 over 9x plus 40 over 9. I could factor out the 9, so I get something like 1/3-ish. I got 3. X over 6. I get this, which is a nice looking number. And then I can just plop everything back in there. Yeah, let me just do that. So here I have x cubed over 6 minus 14 over 6x plus 40 over 6. Or 40. Wait a minute. Did I? Okay, no, I didn't. 40 over 6x. And I can simplify. So I have divide this by 2, right? So here I get, I guess 7 here, I get 3 here. Here I get, what do I get here? A 3 and a 20. No, this one's squared. I almost forgot. Cube. Nice. Okay. Done. Done with the x value. Now I'm going to integrate in terms of y here from 1 to 4. So here, I'm left with this. Or actually, I'll write it in a very unusual, in a very peculiar way. That way I won't be bogged down by the number of things I have to do. Okay, let me integrate. So here we have x to the 4th. Then 4 times 6, that's 24 in the denominator. Then here I get 6, no, here, minus 7x cubed. 3 times 3 is 9. And this one is 20x squared over 6. This one I can do something about. So this becomes divided by 2. This becomes 10. And this becomes 3. 1 to 4. Nice. Then we just do our integration here. 4, oh my god. 4 to the 4th is 256 over 24 minus 4 cubed. That's 64 times 7. Oh my god. 448 over 9. And then this one is 4 squared, so that's 8. No, 16. 16 times 10, 160. Third. Then I subtract that to everything here, that's 1. 124, 7 over 9, 10 over 3. And then that's whatever I get there, that's it. So here I get minus 1 over 24, that's 255 over 24. And then this one I get plus 7. 7 minus 448 is minus 441 over 9. This one I get, yeah, minus 10 with 150. 150 over 3, I think, is a value. It's 50. Actually, let me leave it like this. Now I put all of them to 24-ish. Can't do that. What's the denominator? This is 24. I can divide it by 3 again. 8 maybe. Common denominator. Okay. Oh my goodness. Okay, so here this gives me. I don't want to do it. What the hell? This is a 24. 24 divided. That's annoying. Wait, what's the. This is extremely annoying. Oops, something went wrong. That's funny. After this, I'm gonna take a short break. Just a short one. Okay, let's try. What happens to 441 divided by 3? Oh, so I can do that. Oh my goodness. So this one I got 3. This one I got 147. Lucky. And then I can do this. Well, that 150 minus 147. That's 3 over 3. Oh my goodness. Then that's 1. Then that's minus 1. That's minus 24. 231 over 24. Goodness gracious. I don't get the right answer. Wait, let me see. Can I divide it by 8-ish? Can I do that? What about 3? I get a different answer for some reason. Again. I'm done. It's my off day today. I think it's an off day today, if I'm gonna be honest. Now where did I get it wrong? Let's see. It's probably an off day. X cubed over 6 minus 14x. Okay, now here they factored it out. I really don't know why I'm getting these wrong. Like it's so annoying. This is what slows me down now. I think this is what I have to improve on, just computing these things. Wait, what is this? X squared. So I know I got this. This one is x squared from 6, 20 over 6. 6 and 20, they just become 10 and 3. So this is fine. I plug in a 4 here, I get these values. See, this is what makes it annoying. 4 to the 4th is 256 over 24. This one maybe, what if I simplify it faster? This is 4 cubed. What if I do that? 64 over 9. What's 64 over 9? Is that a value? No, that's not. 64 times 7 is 448 divided by 9. Can I do that? I can't do that. And then this one is times 4. 4 squared is 16. 16 times 10 is 116. So I did get this, right? Check. Now here comes the part where I do it by 1, which should be easy, right? I plug in the 1, plug in the 1, plug in the 1. Okay. And then from here, what do I notice? Now it's a fraction thing, elementary thing. uh, oh, I think I just messed something up. This is 256 minus 1, 255. Wait, this is basically how it is. Minus, then here I just do a plus, here I do a minus, right? That's basically what happened for the most part. So 256 minus 1, 255. Negative 448 plus 7. Oh, so that's where I messed it up. No, I actually didn't. Because 441 divided by 9. Again, nice number actually. So this one is 4, oops, what did I do? 448 is negative 441 over 9. 441 divided by 9 is negative 49. So here, just get this. Okay, I'm seeing some things here. Now I do a check of that. And then I do 160 minus negative 10. This is a plus actually. Okay. Yeah, so it's really just being careful. That's it. Be careful. That's the moral lesson of the story. So here, let me be careful and do this nicely, nice and slow. 24 to here. I'm just prioritizing this. This becomes 8. So I multiply this by 8. Shoot. This becomes 1360. Minus, I also multiply this by 24. 49 times 24 is 1176. Here I get some value. 255 plus 1360 is that value minus 1176. 439. I swear, if I get it wrong again. Okay. Apparently I divide it again. I'm dizzy. Okay. For some reason, I don't know why I can't get it. Like, it should be simple. 255. What? Where am I messing up? Plus. Oh my god, I'm actually gonna. Okay. 256 minus. Where am I messing up? 448 divided by 9. Is it that? No, because I'm. Okay. 441 divided by 9. I have 49 here. What's happening? I got 49. Apparently, I don't get the answer I need to. This is not good. Not very good. Mm-hmm. They do 150 here. Why is this 160? Oh, because it's from here. Yeah, 160. Then I do minus negative 10. Or no, this is just minus 10. Whoops. Oh, I'm dizzy. I'm actually dizzy. Yeah. And then from here, okay, that's this value. And then this one is just a positive 8, 150 times 8. 1, 2, 0, 0. Let me try. Am I doing it correctly now? 279 over 24. Now is this, can I simplify this thing? Ah, finally! Ah, I'm, yeah, I need to rest. That's it for this video. Yeah, that's it for this video. I hope you guys enjoyed me crashing out. I'm kidding. Okay, I'm gonna try to keep it professional. I hope you guys enjoyed computing these things. I mean, if you guys did compute it, then at least I'm not the only ones. Okay, anyway, at least I'm not the only one suffering, I guess. But thank you guys for watching this video. And yeah, I hope you guys learned something. I hope you enjoyed. Keep doing math. It's really fun, except the computation part. But there is definitely something fun about doing math. And yeah, I just hope you guys enjoyed, learned a lot, and I'll see you all in the next video.